Okay, we are covering reading number 9. So in this reading number 9, if you can see that we have these many chapters, so 2, 3, 4, 5, 6, 7, these are the chapters, and the material that they are following is this book, Introduction to Econometrics by James Stock and Mark Watson. Okay, so this is the book we'll be following, and in the part 1 of the quantitative we'll be covering this reading 9 and reading 10. Okay, and we'll be differing the quantitative analysis. Okay, this is other parts will be differing till we cover the letter, that means we'll be going through this in the when we cover the valuation and risk model. Okay, so the idea is that you should be very thorough with the first part of quantitative. If you are able to understand the first part of quantitative, you should be able to understand the basic. Okay, even like over here, if you are not able to follow much, okay, do not worry. Okay, so this is the basic and we should be thorough with this. Okay, so there are lots of aims in this, and the idea is not to cover some of the things like chi-square. So today I would be only covering the standard normal distribution. Okay, standard normal distribution. Multivariate normal, you don't have to worry much about it because from the examination point of view it is not required. Chi-square, student T, and the F distribution will be covering later classes when we cover the hypothesis testing. So then I will be covering this. Okay, so let's see some of the definition in probability. So this is like we are covering the probability. There are some definition in probability that we have. Okay, what is a random variable? So the random variable, if you see, random variable is a variable whose outcome, okay, we do not know. So if you throw a coin, okay, you do not know whether it will come head or whether it will come tail. Okay, so we can say that the outcome of the throw of a coin is a random variable. We do not know. Okay, so what we have is, okay, we have one more. So I have used that word outcome. So outcome is what is called as observed value of random variable. Okay, so random variable whose value is uncertain, we do not know. So either it can come head or it can come tail. Okay, now when we throw a coin, we say that the outcome is head. That means we are saying that the value of the random variable has taken the value of head. Okay, now what you have is event. So in a probability, you know, event is a set of outcome. Okay, it is a set of outcome means like it can be one outcome can also be there. So you can have event as head, or you can have event as head. Okay, you can have event as head and tail. Okay, so you have event as a specified set of outcome. Okay, now what you have is many times you will come across, okay, some events, okay, which are mutually exclusive. Now what is meant by mutually exclusive event? Mutually exclusive event means like only one of the event would happen. Okay, so if you think yourself, okay, you are sitting now in this class, okay, you cannot be elsewhere. Okay, so the presence of your presence is in let's say your presence in cinema hall, okay, is a mutually exclusive event because either you are in class or you are in cinema hall, so you cannot be present both the place. Okay, so what we have is, in case of probability, mutually exclusive event is when only one event is happening at a particular time. So let's say either you are in cinema hall or you are in class. Okay, so you have only one of the event happening at a particular time. So what we say is these are mutually exclusive. Typically we will be using a tree diagram to represent mutually exclusiveness. Okay, so we'll have like a tree diagram like this. We'll say, okay, this is one thing is present, this is another thing is present. Okay, now what we have is we have a concept of exhaustive. Okay, so we have mutually exclusive and exhaustive. Exhaustive means that, oh, if you take all the events, they are covering the entire sample space. Okay, so that means outcome of the event, they cover the entire possible scenario. So whatever the scenarios are possible, you are covering through that. Okay, so let's see over here. Okay, what we can have is, so think about this particular case. Okay, so let's say you are having a head or a tail. Okay, so when you throw a coin, okay, you can either get a head or you can get a tail. Okay, so what you have is this is exclusive. So this is exclusive, this is exclusive. Okay, so these are mutually exclusive. If it comes, this will not come. If this comes, this will not come. But on combine, this and this both together are coming. So what happens is the entire sample space is either you get a head or tail. Okay, you cannot get any other thing. Either you have to get this. If you are getting this, you will not get this. If you are getting this, you will not get this. Okay, both cannot come together. Or also there cannot be a situation where you get nothing. Okay, until unless like the coin drops in the middle, but other that, let's say we ignore that. So we can say that there are only two possibility, head or tail. But what happens is these head and tail are called mutually exclusive, but they are collectively exhaustive. Collectively exhaustive means they are covering the entire sample space. So these are the only two scenarios possible. Think about when you are throwing a die. Okay, so die has 1, 2, 3, 4, 5, 6 numbers, right? So either you get 1 or you can get 6 or 5. So out of these 6 only you will be getting. So it is not possible that you get 7 when you are throwing a die. Okay, so what we say is all these numbers are mutually exclusive, but they are collectively exhaustive. So mutually exclusive, collectively exhaustive. Collectively exhaustive means they are covering the entire sample space. Okay, we are considering every time we'll be covering this probability, we are saying that the coins are unbiased. Okay, the coins are unbiased, the dice are unbiased, so all of them have the same probability of occurrence. Okay, mutually exclusive things are, okay, these are mutually exclusive. Either you get 1 or you get 2, 3, 4, 5, 6. Okay, but collectively you will be getting the entire thing. Okay, so what you have is each of these items will have the probability of occurrence of 1 by 6. Each of them have probability of occurrence of 1 by 6. So if you take the summation of 1 by 6 for all, it will come as 1. So what you will be seeing in the next slide is the properties of probability. Okay, but as of now, can I say that mutually exclusive is either this occur or this occur or this occur, and collectively exhaustive means all of these are covering the entire space. So what you have is you have some properties of probability. Let us cover it over here only. Okay, what is a property of probability? Okay, so can probability be negative? Is it possible that probability can be negative? You cannot have a case probability being negative. Okay, can probability be 0? Yes, probability can be 0. So some of the things are impossible. Okay, so what is the probability that you will be alive without air? The probability is 0. Okay, so what we have is, can probability be greater than 1? Can we have this case? No, probability cannot be greater than 1. You cannot have more than 100%. So when you have 100%, it means that the probability is 1. Okay, so what we have is one of the property of probability is greater than or equal to 0. So we denote px as probability of event x happening. So we say that probability of event x happening is greater than or equal to 0. It cannot be less than 0. So we have it is greater than equal to 0. It can be 0. So equal to, it has to be greater. So greater than equal to 0. However, since probability cannot be greater than 1, okay, we have probability of an event less than 1. But can probability be equal to 1? Can probability be equal to 1? Can we have a situation where probability is equal to 1? Yes, probability can be equal to 1, right? So we have probability is between 0 and 1, both inclusive. So one of the property of probability is 0 is less than x, probability of x is less than equal to 1. Okay. Another property of probability is summation of all the probabilities. So summation of all the probabilities should be equal to 1. Okay, so summation of all the items should be equal to 1. So over here, if you see what is the probability of 1, it is 1 by 6. Probability of 2, it is 1 by 6. Okay, 3, it is also 1 by 6. If you take the summation of all, the summation of probabilities should come as 1. So there are two defining properties of probability, that is probability is between 0 and 1. Second is summation of the probability is equal to 1. So let's see over here, we'll see. So there are two properties of probability, that is some probability of an event is less than equal to 1, or summation of probability is equal to 1 for all the mutually exclusive and collective. So all mutually exclusive and collectively exhaustive event, the summation should come as 1. Okay, so these are the two properties. Now let us try to understand some of the other stuffs which we have. Okay, so we call as mutually exclusive collectively exhaustive event as MICE, mutually exclusive collectively exhaustive. Okay, now this random variable which we have spoken over here, okay, this random variable, it can be of two type. Okay, one case is when the random variable is a discrete random variable. Now let us try to understand what is a discrete random variable. Okay, so where we had seen the scenario where the random variable was a discrete random variable. Okay, because when we try to cover the concept, okay, so think about it. Can I say that a random variable is a discrete random variable in such a case when you can count? So when you are throwing a die, okay, it can come as 1, 2, 3, 4, 5, 6. So these are total of how many scenarios? There are only 6 scenarios. So you can say that the random variable, let's say denoted by x, it can take the value only 1, 2, 3, 4, 5, 6. Okay, these are the only values it can take. There is no other value it can take apart from this. Okay, so it cannot take 7 and 8. So what you have is, you can say that there are only 6 possible values. There are only 6 possible values for this random variable. That is, you can count the number of the number of outcomes. You can count the number of outcomes of random variable. You can count what are the number of outcomes of this random variable. Okay, however, let me try to ask you this question. Okay, let's say you have a line. Okay, you have a number line. Let's say you have a number line. Okay, and in this number line you have one number is 2, okay, and another number is 3. Okay, so number line is from minus infinity to plus infinity, right? So in this number line we have the number is between 2 and 3. I want to ask a simple question. Okay, what is the total number of values between 2 and 3? Okay, how many numbers are there between 2 and 3? Okay, so question is, how many numbers are there between 2 and 3? Can we count that? No, we cannot count that. So think about it. Okay, between 2 and 3 you have a number 2.1. Okay, if you go, you can also have a number which is 2.11. You can also have a number which is 2.111. Okay, 2.11111, like that. You can have infinite numbers between 2 and 3. So we cannot count the numbers between 2 and 3. Okay, so let's say you have a random variable. So you have a random variable which takes any value between 2 and 3. So which takes any value between 2 and 3. It can take 2.1, it can take 2.11, it can take 2.111111, like anything, any value it can take. Okay, so what we say, when you have that random variable, you are not able to count what is the sample space. So over there, for that random variable, if you want to find out the, let's say you denote that random variable by x, you say that okay, it can take a value of 2, it can take a value of 2.1, it can take a value of 2.11, it can take 2.111, it can take 2.111. Okay, there are infinite number of outcomes. So between and up till 3, so there are infinite number of elements for this set. Okay, so when you have, so you have two type of random variable, in which first the outcomes can be counted, second is the outcome cannot be counted. So when you can count the number of outcome, it is called as discrete random variable. When it is uncountable, it is called as continuous. It is called as continuous random variable. So continuous random variable, you will not be able to count the number of occurrence. Okay, so why it is called as continuous? Think about it. So if you think between 2.1 and 2.11, I want to know how many elements are there. You will not be able to find. So again, between these two values there will be infinite number of items, because it can be 2.101, 102, 103, and it can be 2.1030. So there can be infinite number. So what happens is, you cannot say that you are So if you see this number line, you will not be able to see this 2, 2.1, 2.2, 2.3. So there will be not breaks, but it will be continuous. It will be a smooth line. So that is why we say as continuous. So the numbers will be continuous. However, in case of discrete, you are not seeing this line. So if you see the discrete case, you are seeing the outcome as 1, outcome as 2, outcome as 3, outcome as 4, 5, 6. So you are seeing that 1 is there, after that there is gap, and then 2 is there, after that there is gap. So it is not continuous. Okay. Whereas in the previous case, between 2 and 3, if we want, there are infinite number of occurrence, infinite number of values between these items. So between 2 and 3 you have infinite number of values. So what we say is this is a smooth or it is a continuous. Here it is not smooth, it is your discrete. Okay. So what we have is discrete number of possible outcomes are countable. Continuous random variable where the number of possible outcomes are not countable or they are infinite. Okay. Now we have said this. Okay, these are the discrete random variables. However, you can have another thing which is called as probability distribution. Okay. Now what is a probability distribution? We'll cover this in detail. Okay. So I'll just give you a hint over here is it represents the probability of all possible outcome of a random variable. So if you see the probability of outcome of a random variable, the what is when you have when you are throwing a die, what is the probability that x is equal to 1? It is 1 by 6. What is the probability x is equal to 2? It is 1 by 6. Like that we will be denoting. So I will cover this in maybe like a couple of hours. I will be covering on this point. Okay. As of now, what I say is, okay, think of as all possible outcome of a random variable. There is a way to represent, and that a way to represent is through a probability distribution. Okay. So we have covered the properties of the probability. Okay, two properties. Okay. Now there are some other probabilities we have to cover. Okay. One of the probabilities that you will find, okay, many place people say as unconditional probability. Now what is unconditional probability? Unconditional probability is referred as marginal probability. So unconditional probability of an event is also called as marginal probability of an event. So if anybody asks what is the difference between unconditional and marginal, there is no difference. Okay. So marginal probability means like what is the probability of something happening. So what is the probability of coming of head when you throw a coin? Okay. The probability of head coming is 0.5. Okay. So that is unconditional. It means it is not dependent on any other event. It is not dependent on this any other event. So we have been taking a case of fair die. So we have been taking a case of fair die, and what will happen is either it will come as head or tail. So there are only two possible outcome. Both will come. Both outcome will have the same probability of half and half. Okay. So what we say is unconditional probability is regardless of any past or future occurrence of any other event. Okay. Now here I will ask you a quick question. Okay. Let's say you have thrown a coin. Okay. So you are throwing a coin. Okay. Let's say 1 rupee coin, and you have a head over here. Okay. So let's say you have got head, 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 head. You have thrown it 5 times, and all the 5 times head has come. Okay. You are going to throw it for the 6th time. I ask you the question, what is the probability that head will come? What will be the answer? Can I say it will be 0.5? Because we are considering the the coin is unbiased. Okay, it has just by random chance it happened that the past 5 times head has come. Okay, it is not necessary that next time also head will come. The next time the probability of head is still 0.5. Okay, if the coin is unbiased. Okay, many of you might start thinking that the coin is biased. Okay, when you have got head as 5 times, but if you think that the coin is unbiased, the probability is still 0.5. So what we say is the probability of head coming is regardless of any past or future occurrence. So it's regardless of how many times head has come in the past. Okay. It is a unconditional probability, no condition whatsoever. Okay. Then you have the next probability is conditional probability. Okay. Okay, in case of conditional probability, what we say is probability that an event will occur, okay, given that something has already occurred. Okay, so conditional probability is probability that one event will occur given that something has already occurred. So think about a case wherein we say that probability that India will win the match given that Sachin has played. Okay, so it's like mostly we will start thinking that if Sachin plays, okay, the chances of India winning is more. Okay, so it's a conditional probability is like if Sachin plays, what is the probability of India winning the match? Okay, so you have two ways, like we can say unconditional probability as India winning the match. Okay, so which is probability of India winning. Okay, we can say conditional probability as probability that India winning the match given that Sachin has played. Okay, so this is probability India winning the match given Sachin has played. So this is your conditional probability. That means probability that India will win depends on whether Sachin is playing or not. Okay, so what we say is conditional probability that an event will occur given that one or more other events have already occurred. So we are saying that Sachin is playing. What is the probability India is winning the match? Okay, so what we say is probability that B will occur given that A has occurred. So probability that India will win given that Sachin has played. So it is denoted with this. So probability that B will occur given that A has occurred. So given A has already occurred, probability that B will occur. So PB given A. So it is the conditional probability. So and is read as probability of B given A. Probability of India winning given Sachin has played. So this is your conditional probability. Okay, we have events can be dependent and events can be independent also. Okay, so what do we mean by independent events? So when we say that independent events are those events where the occurrence of one event has no impact on the occurrence of any other event. So if you have an event A which is occurring and an event B is occurring, okay, so event A is not impacting the occurrence of event B. So occurrence of A has no impact on the occurrence of B. Okay, or occurrence of B has no impact on occurrence of A. So that means we say that these events are independent. Okay, so let's say the independent events like maybe like Sachin playing in a match. Okay, if Sachin playing in cricket match. Okay, and then Ponting playing in a cricket match. Okay, these are independent event, right? So Ponting is Australian and Sachin is Indian. So there is no dependence whatsoever that whether Sachin is playing or Ponting is playing. Okay. However, let's say that Harbhajan playing in a match, okay, and Ashwin playing in a match. Okay, they are not independent. Okay, maybe if this guy play, he might not play, or if this guy play, he might not play. Okay, or both of them may play, or both of them may not play. Okay, so what we say is here the occurrence of this has an impact on the occurrence of this. Okay, however, occurrence of Sachin and Ponting, there is no impact whatsoever. Okay. Okay. So in terms of conditional probability, what we say is two events are independent. It has to satisfy these two criteria both. Okay, so what we say is probability of A given B has occurred. Okay, so what is the probability that Sachin will play given Ponting plays? So what is the probability that Sachin will play given Ponting play? It should be equal to the probability of Sachin playing. It should be equal to the unconditional probability of Sachin playing, because the probability of Ponting has no bearing on the playing of Ponting has no bearing on the probability that Sachin will play. So probability of Sachin playing given Ponting play should be equal to probability of Sachin playing, and it should also happen the vice versa, that is probability of Ponting playing given Sachin plays should also be equal to the probability of Ponting playing, unconditional probability. Because if this is something, okay, then you say that okay, the probability of Ponting playing is conditional on Sachin playing. So you have to have these two simultaneously occurring. P A given B, probability that A will occur given B has occurred, okay, should be equal to PA. P B given A is equal to PB. So this should be same. Okay. So these are like two important thing for independence. Okay, so if this condition and this condition is not satisfied, okay, then we say that the events are dependent events. Okay, so dependent events are when the occurrence of one event has the impact on the other event. Maybe like if one event is occurring, other event may not occur, may occur. So the probability of the other event is changing. Okay, so make sure like you are able to identify the dependent independent event. Okay, and for two events to be independent, this has to hold true. Okay, now let's see some of the rules of probabilities. Okay, now the rules of probabilities are, one is like multiplication rule of probability. Okay, so we have in multiplication rule, what we say is we want to find out the joint probability of two events. Okay, so maybe like we can use we can try to see this, okay, through a problem. Okay, it will make sense if we try to understand this using a problem. What Binit is saying, that sometimes one team can include another player to counter, like Sachin versus Brett Lee. Yeah, so Sachin is a batsman, Brett Lee is a bowler. So if Sachin they are including, he will include Brett Lee. Yes, true. So it is not so that particular example may be true only for Sachin and Ponting because both are batsmen. Okay, but yes, Binit's comment is true that you can include some other teammate. Okay, or we can say that, let's say Australia and India are not playing together. Australia is playing with Bangladesh and India is playing with Sri Lanka. Here Ponting plays or Brett Lee plays, here Sachin plays or not, they have no bearing. So yes, we can say that when these are playing separate matches. Okay. Yeah, or cricket and hockey team, yeah, we can say that. Okay. Now let's try to understand. Okay, maybe like we can take this particular example only. Okay, that is probability that Sachin will play or probability that Sachin will not play. Okay, and we can have a case where India is winning given Sachin is playing, and we have a case where India is not winning and Sachin is playing. Okay, so we have this. I will explain. Okay, slightly, just give me time. Okay, so what we have is, okay, probability that India wins. India can win even Sachin does not play, and India can lose. Okay. Okay. So what we have is, we have two cases over here. Okay, probability that Sachin plays in a match, probability that Sachin does not play in the match. Okay, let's say the probability of Sachin playing is 0.8. Okay, and probability of Sachin not playing in a match is 0.2. Okay, now what we have is, when Sachin plays, okay, the probability that India will win is, let's say, 0.7. Okay, and it may happen that even Sachin is playing, India will not win, and let's say this probability is 0.3. Okay, now it may happen that Sachin is not playing, then also India can win. Okay, so we have a scenario, and let's say the probability of that is 0.4, that is without Sachin India will win is 0.4, and we can say that probability India winning not winning when Sachin is not playing is 0.6. So why we have this as 0.7 and 0.3 is because these are two mutually exclusive and collectively exhaustive events. We are saying that India winning or India not winning. Not winning includes tie and India losing. Okay, India winning over here, probability is 0.4, and the other is 1 minus 0.4, so 0.6. So these are mutually exclusive, collectively exhaustive, and Sachin playing or not playing is mutually exclusive, collectively exhaustive event. So what we have is, okay, we have 4 nodes as of now. This is node 1, this is node 2, this is node 3, and this is your node 4. So you have 2 nodes over here. Okay, sorry, 4 nodes over here. Okay, 1 2 3 4. Okay, now if you see the node 1, okay, what this node 1 signify?